Our next speaker is Dr. Anirban Roy. Anirban has been engaged as a product manager with the R&D team at forbesmarshall since 2022. He obtained his MTech degree from NIT Durgapur in 2014 and his PhD degree from IIT Gandhinagar in 2020. Previously, he was engaged as a faculty in the department Electronics and Communication Engineering at IIIT Surat. He has 6 journal publications, 12 conference publications, and 1 book chapter to his credit. He serves as a reviewer for the Applied Optics Journal and the IEEE transactions on instrumentation and measurement. His research interest lies in the development of optical gas and dust sensors for industrial emission monitoring. Over to you, sir.
Welcome back, everybody. And now we are going into kind of a conversation. You can call it a podcast if you want, but it's completely up to you. But the idea here is for us to actually interact with the audience. So one of the first things that I want to talk to you about is the point that you mentioned, that the optical domain is actually uh, gaining momentum, both in India as well as globally, right? So in the West, I think it used to have momentum early on, but in India specifically, it has started to grow now. Okay. Same is true for, I think, South Asia, Southeast Asia, and so on. Correct. Yes. So there actually the technology has many different parallels in terms of, say, complexity. On one side, the system is not exactly straightforward. Okay, there are so many interconnected systems on this. The requirement of robustness is another. We're also looking at potentially a compact solution. Right now, the systems may be bulky, but if it is smaller, it's better. It's usually how it goes in industry. And lastly, coming to accuracy. Okay. So my question to you is that, given that there are so many different demands on what an optical system is supposed to do, how challenging is it to balance these aspects?
Yes. Okay. So, that's a very nice question, actually. So, while designing a system, the two major things that we keep a check on is, one is the performance, and second is, of course, the cost. So, of course, there are options that we can put in the system to make it work better, but those could be much higher in price. But we have to balance that as well, because we are looking to build a commercial instrument. So the performance, of course, the specifications are outlined at the very beginning, what we actually need to go for. Our tests, every test that we do, we make sure that we are testing the accuracy, the response time, how the noise levels look like, all the other aspects that actually are in indices of the performance. We keep a check on this right from the beginning in our lab. Apart from this, there are actually various standards conforming to which you can build your system. Okay, so like in Germany, you have the TUV standard. Okay, so TUV has outlined a very elaborate performance criteria for these systems. So if you build it according to that, if it conforms to all of that, they can give you a certificate. Also, they would also test it, and they would give you a certificate. The certificate itself is a testimony that it conforms to these standards, and it has a very reliable and accurate measurement, because they not only test it in the lab, they test it on the field also. Okay, so it typically is put for testing for a few months in the lab and then for a few months in the field. And at least 2 systems from your side is actually tested by them. So they have an elaborate process to test it, and then only they certify. So similarly, other parts of the world also have their own certification systems. India has very recently come up with its own. So India till 2024, it didn't have a certification system. So if we needed to certify, we had to take it outside to other countries. So recently, NPL, the National Physical Laboratory, they have come up with a standard actually that would be applied to things that are built in India. Okay, so they have outlined a criteria which is quite similar to the European criteria itself. But now we have our own standard, and if you want to certify, you just send 2 units to NPL. They would do the elaborate testing and they can certify. So when it is certified, customer can be assured that it meets those performance criteria. It is accurate and reliable for installation.
Yeah, and it's actually an interesting aspect in terms of standardization driving technology.
Yes.
So you don't usually see that even in core industry for that matter. There are specific silos in which this has happened. Again, the West is quite adept at doing this. Okay, but I think we have started to catch on, and I hope we'll make good progress on that. Okay, so that was part 1. Part 2, and this is something I'm always curious about, is your journey from academia to industry. Okay, so we have a lot of academicians in our audience, and this is a very typical question that we get asked: is that if they want to migrate to industry,
Right.
Okay,
Right.
what are the kind of aspects they are looking for? Because it's not exactly a straight path, right?
Sure. Sure.
So, what was your experience like? And I have a couple of follow-ups also on
Yeah.
that.
Yeah. Okay. So yeah, I have heard this question a lot of times after I shifted from academia to industry. So of course, I love teaching and doing academic research also while I was at Triple IT. But somewhere I actually wanted to build systems that go out more into the real world.
Mm.
Okay, that is
Yeah.
what actually drove me to come to industry. Okay, so it means in academia, every day you don't get a scope to put your system onto a stack. You won't get that scope. Even if you build one system, you won't easily get that scope. That's the thing. But here, if you build one, you get that scope easily. You can experiment with it.
Because it is baked
Yeah,
into the
yeah,
expectation.
yeah,
Yeah.
yeah. So that's a much easier way of doing things here. It means you get easy access to these things, which are much more real world, you can say. Okay. And of course, that being said, I also felt that academic research is not that real world, to be very frank. It's of course research, it gives you research publications for a curiosity point of view, it's of course good, it gives us knowledge. But it's, to be very frank, it's not that real world. So
Mm.
those who have a passion to actually come to that real world and actually build something that works in the real world, I think they can think of coming to industry if they have that passion. If they think that appeals to them more. And of course, the skills and expertise I showed, which are required, it's not only the passion that you need, you also need a fundamental base, a knowledge base on which you can build. Okay, so not everyone will know everything, but at least among the domains I showed, you should know some part of it so that the rest you can build yourself. Okay. So some programming skills, some knowledge about molecular spectroscopy, some knowledge about building an optical instrument. Okay. So that you have the basics on which you can yourself build on by learning. That's what. The rest, of course, the work teaches us itself. Okay. As you
Yeah.
grow with experience, you get to see more things. You get to know what is right, what is wrong, what needs to be designed, how. Okay.
What
So
needs to be planned for
yeah, what needs
currently?
to be planned for the next
Yeah.
time. Yeah. So that thing comes up as your experience basically. Yeah.
Yeah. Perfect. So you
Yeah.
partially answered my question,
Yeah.
which was one of the next
Yeah.
one that I wanted to ask, which is a preference between publications and products. Okay. So you did mention that you have a little bit of a lean towards products. Yeah.
Yeah. That's what the thing is. So typically, people who migrate to industry or open a startup themselves, they typically have a more. They're more inclined towards building a product. That's the thing. Okay, so that is what I was saying. If you have a passion, or if you are more inclined towards these kind of things, and you look to forward to a product more, of course, there would be byproducts in the process. You would get patents, you would get publications, you'd get conference visits. Okay, all that you do in an academic environment also. Okay, but additionally, you would get to see engineering in real practice, basically. Okay, where because many of the things that we read in our theoretical books, okay, of course, that's the base on which we build, but we get to see a lot more when we come to the practical
Absolutely.
world. Okay, that teaches us much more. Okay, and that builds up your whole experience as an engineer.
Yeah.
That's the
Yeah,
yeah.
that's an excellent way to put it. The follow up on that was there are a lot of public. So this is something that we discussed with Vinay in the
Yeah.
previous session on the innovation side of things, and we have a session with Amod also in the second half on design thinking. Okay, so one of the challenges I think even academia is facing is that there are a large number of publications that may or may not have applications in real life. Okay, so that's definitely a challenge.
Yeah.
How would
Yeah.
you put that, basically?
Yes. So again, we can't always say that that's not useful, because in
Hmm.
academia, many things are done just out of curiosity.
Agree.
Okay, it's not
Absolutely.
always the target is that it's we need a field deployable thing. Many things are done for scientific curiosity, and that's perfectly fine. That is also necessary. So fundamental science also needs to be probed as much as what applied things are probed. So that is good, but still the amount of people that are moving into the applied part or moving into building their own products or startup, that's still significantly less than what we see in other countries.
Hmm.
Okay, that what we see in India currently. I think that needs to increase. Of course, people who are doing fundamental research is good, or who are doing something that may not be relevant to a field deployable device. That's fine. That's okay. Some people need to do that. But the number of people that who are building field deployable things or who are actually addressing real world problems, challenging problems, okay, every domain of engineering have them.
Yeah.
So if they can just venture out and address them, then that would open a very interesting world for them also.
Yeah,
That's what
absolutely.
I feel.
Absolutely.